All right. Hello, hello. Thanks for being here. I saw some faces at Berlin, and you guys had a long weekend, so happy to see you here. I'm Thibaut Sardan. I will talk today about light clients. And before we start, I would like to ask who of you has ever used a light client? Can you raise your hand if you've used it? I see some shy hands. I would say 20%, 30% of the room. Okay. So to make sure we start and take everybody with the presentation, I will start with really with the basics. So before even talking about light client, I will talk about full nodes. So full nodes are they do a lot of things, but ultimately what they do is they receive, verify, and broadcast transactions. So they listen to the network, they see some transactions, and they will verify according to what they know if the transaction is valid. For instance, Thibaut wants to send 1 ETH to Jack. Thibaut should have at least 1 ETH on his account, right? What they also do is receive and broadcast blocks. So when miners send blocks on the network, they do the same as what they do with the transactions, basically. So ultimately, what they do is they verify the whole blockchain. So basically, they take all the transactions from the genesis to the top of the chain, verify all these transactions, and update the state or the database with a lot of information. On this picture, you can see 3 nodes. So those nodes are connected to each other, and one of them is a miner. So miner is just a module attached to a full node that will basically try to find this nonce and try to find this proof of work. If this happens, if a miner finds a node, we'll send the block around and to other full nodes that will check the block, and if they accept it, well, it will be the new top of the chain. So full nodes, as you see, are the most secure way to access the blockchain because they just check everything, right? There's a little problem to that, is that it is not light anymore to have a full node, right? You need at least 100 gigs of an SSD with 100 gigs of storage. When the database is pruned, you need several core CPU, you need a lot of RAM. So this is not something you can do. Plus, you can do like easily on a small, let's say a mobile or something. Plus, it requires time and knowledge because, well, things evolve very quickly, and you have to keep up with what's going on. So you have to update quite regularly your node. It has to run 24/7. So you have to have kind of basic DevOps knowledge here, and this is not basically what anybody could do, right? My mother couldn't do that. So what people do is that when they want to access the blockchain, they actually use a centralized node. Like this user is actually connected to one trusted node. As you can see, this user is connected only to this node. So if the node is malicious and tells him whatever, like Thibaut wants to send €1, 1 ETH to Jack, and this full node is saying, Thibaut doesn't have 1 ETH. Well, what do you do? Well, you're fucked. Huh? I mean, there's nothing you can do here, and that's the problem. And that's where light clients come into the game. Basically, light clients, or as you can see here, the 2 small dots, they are connected to several nodes. And they are connected to full nodes, and they rely on full nodes for a lot of things. So we're going to get into the details later on, but they do not have to trust the full nodes. So unlike what I showed before, where one user is actually connected to one node, here those light clients, they are connected to several nodes, and they can detect which of them are malicious if they are. Unlike the full nodes, they are actually very light, so hence the name, right? You can run them on a mobile. The footprint is, I would say, 100 megabytes. And, well, you will have quite a lot of data exchange on the network, but this is still, like, you can run it on a mobile. You don't need, like, multi-core CPU or a lot of RAM. And the way they work, and that's where we're going to get into in the next minutes, is they verify all the headers. So basically, on a full node, as I said before, is checking all the blocks from the genesis to the top of the chain. What light clients do is they verify the headers. So here's a simplified representation of what is like what's in a block or what's in a block header. So for those who know what's really in a header, there are thousands of things, and as I said, this is really simplified. I just try to make sure we get everybody on the same boat, and I simplify things, but still, it remains valid. So what we do on a block is that we have a header and we have a body. In the header, we have things like the block number, we have the block, the nonce, the difficulty, we have what we called state root or transaction root, and these things are extremely interesting and important for what we'll see, what we talk about next slide. So what I said is that the light client, they actually, do you hear me? Yeah. They actually, they will synchronize only the headers, which is a lot lighter. So the body is constituted by all the transactions that happened on the network, and they do not care about that. They will just get the headers, and they will check the difficulty of the headers, and they will check the proof of work, meaning that even though they are in a network with some malicious nodes that will provide some wrong headers, they should ultimately be able to synchronize the whole blockchain by just checking the proof of work, right? So light client will download the headers, and those are a couple kilobytes, eventually dump them afterwards, but they will get to the top of the chain with the highest difficulty. And the reason why they are much better than centralized or what we would call thin client, for instance, Ifura or any node that you basically have to trust, is that they, as I said before, they do not have to trust the full nodes, because when they ask something such as, let's say, what's the balance on Thibaut's account, right? They actually check this, and how they can check it is by doing the following thing. The state root, you remember, it's part of the header, right? So the headers are actually checked. So a light client ultimately has the last header of the top of the chain, and this header contains the state root. And again, this is a kind of a simplified, let's say in our blockchain we have 4 accounts, and so 1, 2, 3, 4, and those 4 accounts have 1, 2, 3, 4 ETH, right? And so this is a state tree, or a simplification of a state tree. And what happens is that we have actually at the top the state root, which is in the header that we trust, right? But there's the full node actually have the whole tree, right? They have like they have this tree, right? So when you ask them what's the balance on account number 1, you know that ultimately the state root should be the hash of 1, 2, 3, 4. So basically, what a full node should do is, if you hash this one and this one, you have the hash of 1, 2. Then this one and this one, you have the hash of 3, 4. And then you hash those together, and you get the state root. For those who, I'm pretty sure most of you know, but hashing it right is like a fingerprint so the state root is actually a fingerprint of the state of the blockchain. So if any of these accounts changes, the state root, the hash of 1, 2, 3, 4 will be different. And so when you ask what is the state of the account 1, which is 1 ETH, right? What the full node will actually answer is not only 1 ETH. It will tell you, okay, the state of 1 is 1, the state of 2 is 2, and the hash of 3, 4 is this. So that you, the light client, can actually compute the whole tree and make sure that the full node actually gave you the right answers, so that the hash is corresponding. So if the full node, let's say, is malicious, could be, you will say that the account number 1 has actually 2 ETH. So actually the problem is, here, it will tell you still, because it has to, otherwise the answer is not valid, it will also tell you the hash of 2, the state of the account 2, and the hash of 3, 4. And basically the light client will recompute the whole thing, the whole tree, and will realize, okay, what he gave me as the answer is actually wrong. So one of what the information that he gave is actually wrong. So a light client is actually trustless. It does not have to, to trust any full node. So you might have heard or read that light clients are not participating in the network, right? They are leashing, so to say. They are just asking questions. They never answer anything. So this is actually kind of true from what I explained, but this is totally wrong ultimately, because light client can do a lot of things. So first of all, just like what I explained right now, they keep the network decentralized, right? You can actually have a light client on your mobile. You can, instead of just relying on Infura, you could actually rely on a decentralized network using a light client. Right now, the full nodes are not incentivized to run. It costs quite a lot to have a full nodes running, and there's no incentivization for that. Only the miners get the money, right? And what about a network where the light client could actually, every time they talk to or they ask a question to a full node, they could just give some ETH or do some micropayments, state channels, whatnot. This is doable. This is at Parity actually something that we already have in the protocol. We're not using it, but ultimately we hope to use it. And down the road, or if you heard about Ethereum 2.0, Plasma, etc., if you have, for instance, like a lot of shards, what do you do if you want to make sure that you want to, let's say, interact with a shard? You will not have run a full node, right? So you will have some light clients there. They will be everywhere. So on that note, I want to talk very briefly about what we did at Parity, which is called Parity Feather. This is I'm just going to show you. This is a wallet based on a light client. So you might think, okay, another wallet, like we have 1,000 out there. We don't really want to do a wallet like a full feature wallet. There are really good companies out there who do that very, very well. I mean, I'm talking about, I don't know, like MyCrypto, for instance, to access the blockchain, they use Infura, they could use a light client. And what we do here is actually we build an app that uses a light client to know what ultimately people would do with a light client, see the problems that we could have and make it better. So this is a wallet that is extremely simple, but very powerful. So you can have several accounts, you can have some ETH, you can have some tokens, and as you can see, it's quite sleek, and underneath, it's a light client running. So that's, for instance, a screenshot of how it looks like when you send money. So basically, the three screens that you saw is all of the wallet. It's built on light client, as I said. It's built on a library that we built just for this, which is called Light.js. And it's basically to help any project that want to build an app on a light wallet, a light client, sorry, to be able to use it. To make things simple, everything you heard right now is on the wiki.parity.io. I'm talking about Feather, I'm talking about the Light.js. There's a really cool documentation about Light.js. This is really fresh. This is from last week, by the way. And if you have some questions, we might have some devs around to answer that. Yeah, that was it. Thanks a lot for your attention. And if you have a question, go ahead. Do we take questions? Do you want one question? Do we take questions? Has someone a question? Oh yeah, we have a question. Who's serving light clients right now was a question. Any full node. Any full node, basically, as long as you do not have a specific flag that says do not serve light clients. But Parity per default do serve light clients. Yes?
Have you guys experimented with running light clients in the browser?
So the question was, have you guys experienced in running light client in a browser? With experience, we do not, because we didn't do it. And the thing with the browser is that you need to compile it into WASM. The good part is we are doing everything in Rust, so Rust compiles to Wathem, and the slight problem is that DevP2P, the underlying network protocol that is used right now for Ethereum, is actually not compatible in the browser. So you have to use libp2p, which we have experience with because we're working on that with Polkadot. So ultimately, yes, we hope that this thing will run in the browser, and ultimately we also hope, actually the work has been done on that, I think we're not too far from it, but we will compile this for Android and iOS. But again, our goal is not like to have a wallet out there, it's more to like test our light client and push people to use them because they are so cool. Let's talk later.
Thank you. Thank you, Thibaut. That was great.